Hello, so this paper is about a study we ran to look at how developers store passwords. I'm Joseph Hallett and this is joint work with my colleagues at Bristol Cybersecurity Group at Bristol University. So there have been a number of studies, mostly by Nakashima et al., showing that developers struggle to store passwords correctly. That is, they usually fail to remember even the very basics of hashing and salting. Similarly, we know that the act of writing a specification, a description of how code should work, expressed formally or informally, generally leads to better quality code. So, can we encourage developers into storing passwords more securely if we force them to think about what they're going to do before we let them write any code? Essentially, can we get developers to self-prime for secure password storage mechanisms through specification writing? And the answer is going to be kinda. Yes, we can see a statistically significant improvement in developers that wrote specifications before attempting password storage, but the improvement itself is tiny and the effect size is small. More worryingly though, when we went and asked developers why they were writing the code they did, the developers seemed to say that they thought they were already getting it right, that they knew password storage was tricky, but they were experienced, they'd done it before, they knew what they were doing. Our analysis does not support their self-belief. So our study is a two groups experiment. We got a bunch of developers and we asked all of them to implement password storage in whatever language they liked. Half we explicitly asked to make some form of specification before they started, the rest were allowed to go straight to coding. We scored the implementations and we also asked developers why they did what they did, to gain insight into their rationales. Specifically, it's 138 developers from Prolific Academic, each paid a living wage for their time. 61 were prompted to write a spec explicitly, and all in practice chose to write an informal high-level plan rather than a more formal method. The rest went straight to coding, but 36 claimed to have written a specification of some kind anyway. To score the implementations, we used Nakashima's criteria. It's used in a bunch of earlier papers, and essentially it's a score from 0 to 7, with 6 or more corresponding to industrial best practice. The criteria is basically a codified form of what's in the appropriate standard for good password storage behavior, NIST SP 800-63-3. No one seemed to have looked at NIST SP 800-63-3. In fact, one of the interesting things we found is that when people said they'd looked at a standard, mostly they seemed to look at blogs or API documentation. Right, so results, what do we find? Here are the scores for all the groups we looked at in this study. As well as the specification groups, we also looked at whether people had claimed to look at a standard or not, and whether they claimed a formal software engineering qualification. And the key here is that all groups do pretty universally badly, with 62% scoring 0, that is, storing the passwords as plain text. About 30% remembered the bare basics, hashing and salting passwords to obscure them, to hide weak passwords. No one did it perfectly, and only 2 out of the 138 got to the level of industrial best practice according to this criteria. If we compare between groups with Mann Whitney's U, there is a statistically significant difference between the explicitly prompted specification groups and the group that we didn't ask and didn't claim to write any form of spec, but the effect size, the rank Bisserl correlation in this case, is tiny. In any case, the average scores show that everyone does badly. If you write a spec, you might remember to hash and salt the password, but that is far from storing a password securely. So given that developers all seem to struggle with storing passwords, according to this scoring metric, what were they actually doing when storing the passwords? Well, some developers did remember to hash their passwords, but the choice of hashing algorithm was somewhat questionable. Insecure options like MD5 and SHA, which are not appropriate for password hashing, were preferred over secure hashes like Bcrypt and the PBKDF2 family. Some developers opted to copy their solutions verbatim from the internet. We're suspicious folks, so we stuck all the implementations we got into Google, and yeah, developers really do seem to copy from Stack Overflow. What's interesting though is if you compare between groups again, those that we were pretty sure copied their solution scored significantly higher than those who didn't, though again the effect size was tiny, as was the difference in scores. Another thing we saw is that when developers did tend to copy from a blog post, they tended to copy the first thing on the blog post and get the job done. If a blog post leads with a counterexample, this can be rather dangerous because they don't seem to read through the rest of the article to go and find the bit where it said, please don't do this. Actually do this. Developers didn't read that bit, they just copied the first example. We also asked developers directly why they wrote the code in the way they did, and using a qualitative approach, we built a codebook from analysing their answers. The most common reason they claimed for why they did what they did was, well, that's an easy way to implement password storage. But I want to push into these specific codes we identified a little bit more. Experience, best practice, method justifications, threats, past effort, and advisement. These codes are all interesting as they represent the developer saying they did what they did because they think it's right, because they have experience, they've done it before, they thought about threats, and this is the best way to do it. For example, one developer said, I've been working as a software engineer for 8 years and have developed authentication systems for our clients hundreds of times, so I've come to learn the best practices for doing so. Their implementation scored only 3, which suggests their knowledge of the best practice may be out of date. Other developers again said they knew how to do this task because they've done it before. I wrote a user registration system in the past, said one developer. Another said, I'm used to implementing similar login and authentication mechanisms in university projects, and the thought process is always the same. They scored 0, meaning they stored the password as plaintext. One claimed to have consulted a friend who knew about cybersecurity. They hashed the password but did nothing else. Another considered themselves somewhat experienced in applied security. They knew they needed to store the password securely, but they didn't. Perhaps this is just developers taking shortcuts for an online study. If they did these approaches in a company, we'd hope that the code review process would catch it. We'd hope that the quality assurance processes would catch it. But what if it's a solo developer working alone at home? In this case, maybe they really do implement password storage like this. We've managed to teach developers not to roll their own crypto. Well, maybe we need to extend that to not rolling your own authentication systems too, because despite developers seeming overly confident in their abilities, all the research we have says they routinely slip up. Though maybe this really isn't their fault. There's this lovely quote from Harry Truman on what it's like to be the US president. Truman says on the topic of presidential power that, well, he'll sit there and he'll say, do this, do that, and nothing will happen. Perhaps we see something similar in the security community. We keep telling developers to remember to hash and salt passwords, to look at the standards, and we keep being surprised that nothing happens, that they don't do it, and instead assume they know how to do it. I started this paper with an experiment essentially trying to trick developers into storing passwords securely, and yes, specification does lead to slightly more secure password storage mechanisms. But perhaps that isn't the point. We talk in usable security about fitting the task to the user. Or maybe we need to fit password storage to developers and stop giving them crypto primitives instead of do store password APIs. Maybe we need to stop saying hash this and salt that and pointing at the standards and being surprised that nothing has happened, and instead think about how we can help developers get it right. Thank you for your time.
Hello everyone again, and welcome to the query and answers of our second paper. We have here with us one of the authors, Joseph Hallett, and I can see that there are already some questions burning on the chat. I will fire the first one, Joseph, if you're ready, from Ross Gardiner. Ross says, I've often seen repeated the mantra, just use Bcrypt. Did you see anyone call this approach out by name, and was it sufficient for your criteria?
So for us, when we were doing the coding, if they said, I'll just use Bcrypt, yes, they would have scored an awful lot of the points. Not all of them, as I remember. There are some of them which require you to configure it a little bit. No, we didn't see anyone take that approach directly. We did see people say things like, oh, I'll just use the standard password hashing one of these things here and I'll do it sensibly. And I think they generally scored okay. But no, mostly we saw people use things like MD5, which was a bit worrying from our point of view.
Thank you. We have also another question from Mauricio Anici. Thanks for the presentation. And the question is, why did you hypothesize that writing requirements before coding would make developers to better reason about how to implement the task?
So this paper actually it came from a wonderful Darkstall seminar, and in the gardens at this wonderful venue afterwards, we had two professors arguing about whether specification actually will lead to a measured improvement in security. Because we kind of know that specification is good for software engineering, but the links to then that leading to an improvement in security haven't ever really been shown empirically. We sort of believe it to be the case, but we don't really have any hard evidence, as far as I can tell. So, okay, let's try and answer that discussion with it between two profs and say, well, okay, is this actually going to lead to a measured improvement in performance? Again, a lot of this is about trying to get developers to do security properly, because we have had this crisis where we've known how to do it for years and years and years, but it never seems to quite make its way through to the developers. So, it is about asking these questions about, how can we actually get developers to program security when their kind of natural inclination seems often not to be. Are there any things to make them go, actually, oh no, I should think about the security aspects here. I should go and look up the standards. Specifications seem to be an interesting way of trying to do that.
Thank you. We have also another question from Lutz Pretschel. Lutz is asking, software reuse is as much about quality as it is about productivity, right? Isn't that the main lesson?
So software reuse is great. Again, partly because it saves developer time, but partly also you hope the things you're reusing are good. What was kind of interesting we saw with the study is when people were reusing, snippets of code from blog posts, they weren't taking the high quality ones, they were taking the first ones. We had a paper at ICSI last year as well, where we looked at how developers choose answers from Stack Overflow. And again, we find the same sort of effect where we see people taking the first answer off a blog post, off a Stack Overflow answer, rather than necessarily the most high quality one. So yeah, software reuse is great, but you also need to be able to reason about what it is you're reusing. You do need to have a think about security, and you need to consider that. If we can get developers to always reuse, perfect password storage mechanisms, for me, yeah, great, fabulous, problem solved. But developers aren't doing that. They're not just reusing perfect solutions. They're taking essentially the first thing they can find in some cases, which is worrying.
Okay, thank you. I have a question, Joseph. By seeing your presentation, it occurs to me, how do you really motivate developers? How do you make them change their habits? Because it's important, we all know, but how can we make them change?
I think there's two sorts of developer here. So in an organizational context, of course, there's motivation to change developers' practices, right? Because we have code review processes, we have quality assurance processes inside any reasonable sized organization following any reasonable, kind of traditional software engineering model. For me, they're not the ones we need to worry about, because traditional processes will catch that to an extent, right? We will do code review, we will see that passwords aren't stored. For me, it's about getting the solo developers, the people who are writing apps on their own, making a website, and there aren't always those quality assurance processes built in there, because it's one person on their own. How do we make people care? Well, what was kind of interesting about this is the developers did seem to care. They knew how to do password storage. They said, I'm doing it correctly. I've thought about this and I know what the right answer is. What's interesting is that knowledge they perceive themselves having isn't necessarily in lockstep with what the current best practice is. That's kind of worrying. Now, how can we encourage people to do that, to go and look up these things? Well, we can try and make it interesting, but unless you're having these pushes in for developers to go and say, have an interest in this, they're not going to. For me, I think the best way to do it is to start putting authentication mechanisms out there as libraries, not just things like Google Tink, where they go and give you a fairly usable set of crypto primitives, but they're giving you crypto primitives rather than, look, this is the magical button which just does authentication and just does it right. certain approaches like federated identity can give you some of these guarantees. You know, here is Facebook. Facebook will do all your login for you and they'll get it right, more or less. But there's a whole bunch of other issues associated with this, and not everything is online all the time. So that, for me, we need libraries. We need to automate this process. We need to not roll our own crypto and not roll our own authentication either. And then maybe developers don't have to care about all this stuff. Maybe we can get away from this problem of, you know, being security people and saying, no, you really do have to fix all this stuff, and get away with building apps. Because at the end of the day, it's not about the authentication mechanisms we're building into our software. It's about the software itself. It's about having that do something useful, do something wonderful. We're not building software just for the sake of building software. So that is fun.
Thank you. And through your study, did you have anyone saying, oh, I don't have time to think about these things, I'm under pressure?
We didn't see that here. Mostly we saw people saying either I knew about it or, oh, and I didn't think about that. Oh, I probably should have done. Sometimes we saw. That was quite interesting. People kind of knew they should think about security, but didn't. Now, whether that's because we're taking, you know, developers from an online survey site, it's always going to be a problem when you're using that kind of instrument. It's interesting, though, that a lot of them did seem to think they knew they were doing it right, which is kind of fun.
Good, thank you. There are no more questions on the chat. Oh no, I'm sorry, my fault. There is another question from Daniel Sokolovsky. Can you comment on the impact of the Hawthorne effect on your study? I'm wondering that the results are that bad, even though devs knew the access.
I don't know what the Hawthorne effect is off the top of my head, I'm afraid, so I worry about that. But there's been an awful lot of work that says, again, go read Sheena. We have shown developers really struggle doing password storage again and again and again. In a kind of way, this is, you know, further empirical evidence for this further replication of this result. Yes, it's terrifying that it is this bad. Yes, it's really surprising, but it really does seem to be that bad.
Okay. There is a question also from Alexander. Are developers not aware of this practice or do not care about them?
So I think they are aware. One of the things, so some developers definitely aren't, and you know, they made no reference to security, and they said, oh, I didn't think about security at all. I don't really know the right way of doing it. I think they do care. I think everyone cares about the quality of their work. And again, that we had a lot of people answering, you know, I've done it right. And they were hashing with MD5, not salting and not doing anything else. I think it's a question partially of awareness, but I don't think it's not necessarily not care. I think they do care.
Okay, we are running out of time, and we will